Buenas tardes a todos, supervivientes del AWS Summit 2018. Si me pongo aquí, se ve lo de atrás. Me separo un poco para los que estéis en primera fila posiblemente. Me presento, soy Carus, soy el responsable de la Oficina de Tecnología y de Arquitectura de Amazon Web Services en Iberia. Y hoy os voy a hablar un poco de algunos ejemplos prácticos de algunos clientes que tenemos por todo el mundo que están utilizando las soluciones de inteligencia artificial de Amazon Web Services. La charla va a estar relajadita. No vamos a tener el nivel de profundidad, por ejemplo, nuestros amigos de FinTonic tuvieron antes, con lo cual, si estáis esperando un elemento de profundidad, encantado de hablar con vosotros luego y tocamos los temas que queráis. Esta va a ser un poco más tranquila para que ya os vayáis con buen sabor de boca del Summit. Le voy a dar al botón y entonces esto automáticamente empieza a funcionar, ¿verdad? Y cuando hablamos de inteligencia artificial, y supongo que si habéis estado en este track, esto es algo que se ha tratado bastante, hay varias formas de acercarnos a este mundo, ¿verdad? Podéis utilizar desde soluciones que ya están perfectamente paquetizadas, en las cuales nosotros ya teníamos catálogos de datos, entrenamos un modelo, el modelo vemos que tiene unas probabilidades de éxito bastante altas, generamos una inferencia, damos un endpoint y al final lo que creamos es una API, es una petición web, básicamente, en la cual vosotros enviáis los datos y el modelo os responde. Este es más alto nivel, ¿verdad? Son soluciones muy específicas, que nosotros tenemos unas cuantas, y que vosotros, si os encajan, oye, maravillosamente, las podéis utilizar. Bajando un poco en el nivel de complejidad, anteriormente estábamos hablando de SageMaker, y SageMaker con los distintos sabores que tiene. Pero la idea de SageMaker, al final del día, es que nuestros científicos de datos tengan una herramienta que sea bastante fácil para ellos, para empezar a trabajar, que con golpes de ratón pues ya tengan su notebook de Jupyter, o lo que realmente necesiten, ahí empiecen a trabajar. Con otros golpes de ratón hacemos el training, definamos hiperparámetros si nos hace falta, cómo esos hiperparámetros nos ayudan a optimizar o no el resultado del modelado, y luego a otro golpe de ratón que nos den una inferencia ya funcionando con un clúster de servidores. Bueno, y ahí ya puedes trabajar tú con tus propios modelos. Puedes ir más abajo directamente y decir, pues mira, yo tengo conocimientos de TensorFlow, Gluon, Coffee, lo que más rabia queráis, y utilizo esos frameworks. Podéis ir más abajo todavía y ya decir, pues mira, yo soy un experto en PySpark o, bueno, cualquiera de las herramientas, tanto Python, R, que os podáis imaginar, y ya trabajo directamente mis modelos sobre ellos. Os voy a intentar dar unos ejemplos de todos estos distintos casos, desde los clientes que están utilizando soluciones que ya están perfectamente hechas por nosotros y dicen, este modelo me encaja, me viene muy bien, oye, lo voy a probar, y os van a intentar explicaros cómo lo usan, hasta elementos más abajo. Y luego, pues nuestros amigos de FitSite, que tenemos aquí a Diego Guerra, vendrá como cliente y os explicará cómo ellos hacen pues una serie de elementos predictivos directamente pues con sus propias herramientas. ¿Alguien sabe quién es este señor? Esta cosa simpático, fea, extraña. Este, si os fijáis, más o menos, bueno, ahí por arriba veis que aparece el logotipo de la NASA. Esto se parece a un rover de los del Mars rovers que la gente tiene, bueno, que la NASA tiene en Marte. Ellos están utilizando este aparatito para fomentar la adopción de las tecnologías científicas en los colegios con niños pequeños. Entonces tienen este aparato, este robotito, que es una réplica no tan real como un rover, pero lo llevan a los colegios y los niños pueden hablar con el aparato y le pueden preguntar cosas de Marte. ¿Qué días hoy en Marte? ¿Qué temperatura hace hoy en Marte? ¿Cómo está de lejos Marte? ¿Yo puedo respirar en Marte? Este tipo de cosas. Y el robotito directamente analiza esos datos, esa voz que el niño le dice, se conecta a nuestra cloud de IoT, coge los datos de donde corresponda que la NASA los tenga disponibles, los devuelve, utiliza otro servicio nuestro que se llama Poly, que hace un text-to-speech, y el robotito habla directamente a los niños. Es un ejemplo de cómo utilizar este tipo de soluciones de nuevos elementos cognitivos para que la interacción entre un ser humano y una máquina pues sea más agradable, ¿verdad? Que este robotito pues no tenga que un teclado delante en el cual tengas que empezar a teclear, una pantalla en la cual tocar. Directamente tú hablas con él y utilizando servicios como Amazon Lex o Amazon Poly, pues este robot es capaz de hablar con los niños, ¿no? Y tener esas conversaciones un poco más elevadas. Esta foto que tenéis aquí es la arquitectura muy a alto nivel de cómo la NASA está utilizando pues, nuestras soluciones de IoT, hablando con unas funciones lambda que cogen Amazon Lex. Sabéis que Lex es una de nuestras herramientas que es capaz de reconocer el lenguaje, de ahí sacan toda la información que necesitan, piden los datos que correspondan directamente a los endpoints donde está la información, por ejemplo, temperatura en Marte, pues directamente la tienen ahí almacenada. Todo esto se devuelve a Lex, que es como nuestro chatbox, y a través de Poly se transforma esa respuesta en un texto que el altavoz del robotito puede hablar. Con lo cual los niños tienen esta interacción muy elegante, digamos, con un robotito que para ellos es muy atractivo. Otro caso, el Washington Post, periódico que tiene el reto que tienen casi todos los periódicos y sobre todo las empresas editoriales en el mundo, que es intentar asegurar que el tiempo de ocio que tienen las personas lo dediquen a leer el periódico y no lo dediquen a leer un Kindle o salir a correr o hacer cualquier otra actividad. Entonces, el Washington Post lo que estaba intentando es ¿cómo consigo yo asegurarme de que cuando alguien entre en mi página los contenidos que yo le presenté a ese usuario sean lo más relevantes para esa persona? Entonces, lo que estaban haciendo el Washington Post es analizar los intereses de cada uno de los lectores y, según esos intereses, coger las noticias que tienen en el día y hacerte tu editorial específica para ti. Y esto lo estaban haciendo con uno de nuestros servicios, que es Amazon Comprehend. Comprehend es un servicio, supongo que ya en alguna de las sesiones anteriores os han hablado de él, pero básicamente le dais un texto y Amazon Comprehend es capaz de sacar información de ese texto, palabras claves, análisis de sentimientos sobre un texto, os da toda la información sobre un tipo de noticia, con lo cual tú puedes categorizar automáticamente esas noticias y, en el caso del Washington Post, ofrecerle soluciones de periódico customizado a cada uno de los usuarios. NLP, bueno, esto ya sabéis perfectamente cómo es, y esto lo están utilizando para sus 100 millones de lectores en todo el mundo. Otro caso, este también es bastante típico. Si os fijáis, uno de nuestros servicios de inteligencia artificial en API, ya con modelos entrenados, fue, de hecho, bueno, primero exactamente fue Recognition. Recognition al principio, en las primeras soluciones que daba, era, tú le mandabas una foto y te decía si había una cara. Tú le mandabas otra foto y te podía decir entre las dos caras cuál era el porcentaje de parentesco, con lo cual podéis decir, esta persona se parece a esta. Bueno, iba avanzando. Luego le sacamos otro modelo entrenado que era, tú le mandabas una cara y te decías esa cara la de una persona famosa o no. Con lo cual yo podía subir mi cara y me decía que yo soy un don nadie, pero subías la de Michael Jordan y te decía, este tío es Michael Jordan. El modelo te daba estas cosillas. Otro de los siguientes modelos que tenía entrenado es la capacidad de reconocer el texto en las imágenes. Y esto es algo que nuestros amigos de Pinterest están utilizando. No sé si utilizáis Pinterest o no, pero esta gente, bueno, como sabéis, sacáis fotos, las subís y la gente crea digamos, historias con las fotos que se van utilizando. Los llaman los pinners. Pinterest tiene unos 200 millones de usuarios, es un volumen muy grande, y tiene una cantidad de imágenes que estos usuarios suben constantemente todos los días muy importante. ¿Qué pasa? El usuario cuando sube la imagen pues puede poner un texto o no puede poner un texto, pero la gente de Pinterest lo que querían saber también es si en la foto que yo subo aparece algún texto en algún sitio, eso es información que a mí me interesa mucho para catalogar esa imagen y poder ofrecérsela a otras personas que estén buscando información. Y eso es lo que nuestros amigos de Pinterest estaban haciendo. Tener una API extremadamente rápida, una API que funcione con un volumen inmenso de imágenes diarios y una API que sea lo suficientemente fiable para que sea capaz de reconocer esos textos que aparecen en las imágenes y yo ya pueda catalogarlas y almacenarlas en distintos buckets o tener una serie de metadatos que me permitan coger esas imágenes y luego mostrárselas a los usuarios correspondientes que estén buscando esa metainformación a la hora de intentar navegar por el catálogo de imágenes de Pinterest. Hoteles.com. Esto, bueno, como os lo cuento si no lo sabéis, hotels.com o en España hoteles.com pertenece al grupo Expedia. Hotels.com pues es un, yo no lo llamaría bedbank, pero es un lugar donde, bueno, ya lo sabéis, podéis contratar un hotel directamente en cualquier lugar del mundo. Al igual que nosotros en Amazon.com en retail, hay un elemento que es muy importante a la hora de decidir si yo voy a escoger un producto u otro. Y cuando digo un producto u otro, hablo de nosotros en retail, pero para la gente de hoteles es un hotel u otro, que son los reviews de los usuarios. Cuando una persona ha estado en un hotel, esa persona escribe un texto, pues este hotel me ha gustado mucho, o esto está fatal, está lejísimos de la playa, o no tiene parking, el catering es bueno, es malo. Toda esta información, muchos de nosotros la utilizamos, revisamos lo que otros usuarios han descrito de ese hotel para ver si ese hotel realmente es relevante, coincide con nuestros gustos, o nos gusta o no nos gusta. Pues bueno, hotels.com lo que nos decían es, mira, yo tengo... mi website está realmente dividido en 90 websites distintos para distintos lugares del mundo en 41 lenguajes. ¿Qué ocurre? Que en el lenguaje número 1 pues hay ciertos reviews de usuario. En otro lenguaje, otros reviews. En otro, otro. Y al final lo que ocurre, que los usuarios solo ven las revisiones de los hoteles que están en su propio lenguaje. Entonces esta gente lo que están utilizando es uno de nuestros servicios, también ya entrenados, que es Amazon Translate, para pasar esos reviews de un idioma a otro, de forma que cualquier persona pueda ver los reviews del resto del mundo, sin tener que ver simplemente los de las personas que tienen su mismo idioma. Esto les permite que esa información que tienen de los hoteles esté disponible para todas y cada una de las personas que utilizan hotels.com. Ellos dicen, bueno, unos 25 millones de customer reviews que están traduciendo de un idioma a otro para asegurarse de que la metainformación, todos esos datos extra que ofrecen de sus productos, de sus hoteles, esté disponible para todos y cada uno de nosotros. Este es otro clásico de toda la vida. Estos, pues evidentemente, lo que nuestros amigos de Tinder hacen es evaluar los swipes de dedito con un objetivo fundamental, es intentar analizar cuál es el tipo de perfil que más se adapta a cada uno de sus clientes. Entonces, bueno, pues Tinder lo que tiene son millones de usuarios, dicen que gestionan billones de swipes de estos del dedito todos los días y su objetivo es, dentro de todo el catálogo de personas que están dentro de su base de datos, cuando un usuario está haciendo ese movimiento, gestionar todos esos datos, entrenar modelos, de forma que la siguiente persona que aparezca sea lo más compatible con cada uno de nosotros, o no, o de quien, yo no lo uso porque si no mi mujer me mata, pero bueno, con cada una de las personas que utiliza, en este caso, Tinder. Y es curioso porque ellos utilizan SageMaker. Visteis que antes teníamos una charla de SageMaker, con lo cual el algoritmo es de ellos. Simplemente utilizan SageMaker para, con su modelo, directamente entrenado y definido por ellos, poder ponerlo en producción rápidamente y gestionar esos billones de deditos para un lado, deditos para otro, que la gente pues hace cuando intenta buscar una pareja que se acuerde a sus macheos. Dicho esto, os voy a poner otro ejemplo de cómo, bajando ya un poco más a bajo nivel, cómo la gente utiliza los servicios que nosotros tenemos para integrar y crear soluciones que yo creo que nos pueden ayudar a cambiar la vida. Os voy a poner un pequeño vídeo. Espero que no lo hayáis visto. Si lo habéis visto, pues bueno, yo creo que es interesante volver a verlo. Me voy a poner por aquí detrás.
My name is Troy Larson. I work for Amazon Web Services as a DevOps Cloud Architect, and I focus on automating solutions and building out code deployment. My son is named Calvin. He's 16 years old, and he has autism.
What's your name? My name is Calvin, yeah. And how old are you? Look at the camera. Look at the camera. How old are you?
You're 16 years old.
You're 16 years old. And what's your teacher's name?
It's Bauer.
Okay, so he can answer basic questions, but when it comes to spontaneous, that's when be cool.
As he is growing into adulthood over the next several years, the services may not be as abundant for him as we might need. And so how do we help him to transition to adulthood, potentially even to be able to live somewhat semi-independently without having to have constant physical supervision? He was diagnosed when he was 3 years old, and he's nonverbal, so he can speak some words, but he's not able to have a conversation. For Calvin, the challenges of living independently are primarily around his own personal care and safety. So things that we take for granted, like brushing your teeth and showering and going to the bathroom, those are things that Calvin won't do unless he's prompted. When he's at school or he's at home, we can tell him to do something and he'll follow through with that instruction. One of the challenges with autism is every child is different. There's things that they get and there's things that other ones don't get. And so you're always trying to find that one key to unlock that understanding. Verbal interaction has always been his key. So voice was the technology that we were waiting for to really build a tool that might be able to help with Calvin's communication. When Polly and Lex were announced, it was actually a system where we could actually build communication on the fly. So the first time I used the technology, I did not have Polexi yet, it was just playing with Polly. I had my laptop and we kind of hid around the corner of his bedroom.
Please push the
and
button.
I had Polly say, Calvin, it's time to go potty. Let's take a break and go potty. And we waited a few seconds and all of a sudden his door opened and he walked out, quizzically looked at us like, what are you doing here? What time is it? It's time to...
ICT.
And at that point, I knew, yes, this could be something that we could definitely leverage because he understands that voice. The idea behind Plexi is to build a system that is aware of a person's specific physical needs and is built around the ability to prompt them to give them that quality of life, that sense of confidence where they can function almost independently, and it's invisible, it's not intrusive. Tell Plexi with Brian, tell Calvin, come downstairs.
There was a problem with the requested skills response.
Tell Plexi with Brian, tell Calvin, come downstairs.
Got it. Publishing message, come downstairs to Calvin at location Calvin's _ bedroom.
Please push the blue button. Good evening, Calvin. Do you want some pops? Come downstairs right now to the kitchen to get some pops. Good evening, Calvin. Do you want some pops? Come downstairs right now.
One of my concerns with this project was that we're trying to automate parenting with Calvin. And that's not the case. The idea here is to give him a sense of freedom in the same way that we all want that sense of freedom. We don't walk into our kids' bedrooms every 5 minutes, checking on them and telling them what to do. And the idea here is to give him that respect of privacy and keep his stress level down.
Okay, now brush your teeth.
And it was cool because there was no physical person in the room. There was no face. There was no someone tapping him on the shoulder. It was an invisible voice that he responded to. And that's very chilling to think about, in that you're wanting to have a conversation with him all the time. And when you're able to find something that can communicate with him and that he can understand, your brain just starts wondering, how else can we use this?
A mí, siempre que veo este vídeo me queda un nudito en la garganta, pero cada vez que lo veo también me doy cuenta de que la inteligencia artificial es un elemento que puede ayudarnos de una forma increíble a cambiarle la vida a la gente. Es algo que yo creo que todos los días me hace levantarme por la mañana para decir, oye, tengo una oportunidad de todas estas cosas que estamos haciendo, ofrecérselas a todo el mundo, porque podemos desarrollar negocio, pero también podemos ayudar a cambiar la vida a la gente. Para mí es algo increíble, extraordinario. Si algún día tenéis la oportunidad de hablar con Troy, es un tío genial, muy majo, y la verdad es que es uno de estos ejemplos prácticos como cuando realmente hay algo que te motiva y puedes utilizar la tecnología para trabajar en ello. Los efectos son extraordinarios, son increíbles. Este proyecto está disponible, todos lo podéis utilizar en casa. Utiliza hardware commodity, es súper barato, Raspberry Pis, botones de IoT, no hay nada extremadamente complicado y caro. Y está todo en GitHub, con lo cual cualquier persona podría cogerlo directamente y desplegarlo en su casa tranquilamente. Para mí, me voy a quitar de aquí si estáis sacando fotos. Ya os digo, es uno de estos casos prácticos de donde la inteligencia artificial va un paso más allá, y yo creo que es lo que todos, como miembros de la comunidad tecnológica, deberíamos estar empujando para asegurarnos de que realmente nuestras actividades tienen un impacto, ¿verdad?, en la sociedad. Dicho lo cual, vamos a hablar ahora de un caso práctico y también de cómo la inteligencia artificial nos permite, pues eso, mejorar sistemas de negocio, y para ello me gustaría presentar a Diego Guerra de Fitsai. Lo habéis visto algunos, bueno, supongo que habéis estado todos en el keynote y lo habréis visto, y ahora nos va a contar un poco cómo su empresa está trabajando también en elementos de inteligencia artificial. O sea que, por favor, un aplauso para Diego.
Thank you. Okay, so I'm Diogo. I'm the VP of Engineering at Fitsai, and as Carus was saying, sometimes we look and the market look at us as a fraud prevention company, and it's all about detecting fraud and save money. But in fact, our goal and our mission is to be able to create a better user experience through machine learning while doing commerce. One of the problems that creates friction is because there is fraud, then companies, websites, anyone that does different types of commerce starts to put some more gates. It will ask you more things. It will put more authentication factors. It will do all sorts of things to basically try to make sure that you are not a fraudulent user. And our goal is to, by enabling machine learning, be able to make it as frictionless as possible, so that all of those verifications can be removed, but still, of course, making sure that who's on the receiving side also doesn't have a problem that they need to deal, which is fraud. So this number is a bit outdated. You've seen in the keynote, which is the more updated one. At FeedSci, we protect over $2 billion of transactions per day. We are now reaching the $5 billion a day as we speak. And just to give you a comparison of how much money is this, so we are talking about 1,000 billion or $1 trillion per year. And to put that in context, since 1958 to 2016, the full budget of NASA, updated to the inflation, was around 862 billion. So all of these years, and basically we process more than that, much more than that, in just 1 year. And we need to do it at scale, because we are not dealing with transactions that worth millions of dollars. Many of these transactions are $1, $5, 1 euro, 2 euros. So all of this is nowadays being run in real time. To give you a sense of how fast this needs to be, and applying machine learning and all of the verifications that we need, we in general are operating under a 5 milliseconds window. Okay, so every time a transaction comes to the systems of our customers, we need to respond really fast. We need to respond between these 2 to 5 milliseconds to make sure that the response time for the user is not even perceptible. And we do this, we are not looking only at the averages, even the highest percentiles, and we look many times at the 5 nines. We do it, and we strive to do it under 100 milliseconds. What this means at the same time is that if you are doing this type of loads, you won't be able to do this type of latencies and SLAs of performance, even if the system just glitches for a second. And we really went through these situations in some of the customers where the system just had a glitch of 1 second, and it really violated the SLA. And of course, availability is something that no one questions nowadays. We need to, of course, deploy this also with the same availability that any service is provided today. 99.95 is the standard SLA of any vendor out there, but in fact our customers are pushing us to do higher SLAs and guarantee higher SLAs. And we are basically across the globe. These are just some examples. We work with top financial institutions, from the largest payment processor in the world, which is First Data. I've demonstrated Lloyd's early in the morning. We have Starbucks, we have Nike. So we work with a lot of companies that are nowadays trying to guarantee that commerce is safe. So now I'm going to enter on a bit on what are our challenges while using machine learning for fraud prevention. So one of the challenges that we have is the size of the data that we use. If you go in general to certain types of machine learning use cases, you're dealing with data sets of 50K records. This is already a good data set for many of the machine learning applications. However, our average data set is 5 billion records. And why is this important? Because when you are training models and you want to do machine learning, there is a lot of value that you can bring by iterating, optimize your models. If you are dealing with data sets that are very fast, very large, you cannot iterate that fast. So the thing here is, if you cannot train fast, it's almost like you're not training, because you won't get a really good model. And this is why it's super important for us to then leverage a number of different techniques like distributed processing. We cannot just train and run models in one machine. We need to do it in a distributed way, and also leverage other techniques like sampling of the data sets. So the second problem that the size of the data brings is that because you have a lot of data, you need to decide the amount of data that you want to use. So in this chart on the y-axis, we have the recall. I mean how much fraud, because it's our use case, how much fraud are we really detecting? And on the x-axis, we have the time, where you can see in the blue bar the amount of data that we used for training the model. On the green bar, what we have tested. The white bar we didn't use. So this is the first example that we have here. And then if we go, okay, let's use a little bit more of data to train the model. And we were able to increase the recall of the data set from 40-something points to 75%. So, okay, it means that as much data as we use, the better the model will get. However, that's not always the case. And this is based on real data, on some of our projects. Then we have this third example where, in fact, we took a very different approach, where we just used a very small subset of data, but very recent data, and we got even better results. So the point here is, more data is not always better, but less data is also not always better. The amount of data is just another parameter that we need to optimize. And as more data you have, the bigger the problem, because you have a lot of data to play and to understand where is the sweet spot. The third challenge I wanted to talk is the imbalance of the data sets we work with. So we worked with supervised machine learning. With this, it means that for every record or every transaction, we'll have to know the ground truth, or a human or a system that has previously labeled the data. So every transaction we say it's fraud or it's not fraud for training our models. The literature usually considers an unbalanced data set where we have a ratio of 9:1. So in our use case would be 9 transactions that are not fraudulent to 1 transaction that is fraudulent. And there are a number of techniques to work with this. But what we see on a daily basis is our data sets are by far with this type of unbalance, and we see many times 10,000 transactions to 1 in our data sets. And if some of you also are from the space, one of the things that we could consider is, okay, let's try some of the techniques of anomaly detection. It might really be a good situation to, or a good technique to fight fraud if you have this type of unbalance. However, let me just give an example of why we cannot use this. Imagine that you are a very rich person, so probably sometimes you will do some high amount purchases. Maybe you are going to buy a $50,000 watch or a $1,000 ring for your wife. This is an anomaly. However, in general, this is not fraud. So we cannot treat this as fraud based on an anomaly is fraud. So it's very challenging for us because we are not looking for the anomalies. What we need to understand is we need to encode in the model what is normal for every type of customer, and then find the deviations where we find that risk. So a number of ways that we deal with this, and one of the concerns we need to deal with this when we are dealing with this type of data sets is, as I mentioned, we need to sample the data to basically reduce the volume of data that we use. But with this type of characteristics, it's super easy that you basically lose fidelity of the data. So you will lose patterns once you are reducing the data set. So it's one of the things that we invest really a lot of time is how do you sample the data, how you stratify your data, because you really need to capture all of this information. And it's basically impossible to be iterating that fast with data sets that can have terabytes of data. We want to be able to iterate hundreds of models per day and not just a few dozens. So now I'm going to go through which algorithms we use. Fraud prevention is a very specific space, and there are a lot of algorithms out there that we try and we use every day, and we try to see if they adapt to different types of fraud. But these are the 4 algorithms that we work today. So random forest has been around for 10-15 years, and it has been our champion in our customers. So the majority of our customers are running on random forests. Then we started using SGBoost and isolation forests that we already have in production, but still in a few customers. It really depends on some of the characteristics of the data sets. And with deep learning, we have been, of course, trying and monitoring if deep learning would be something that would be relevant for fraud detection, because it has yielded very great results on language, on text, image, and voice as well. But on fraud detection, we have tried it the first time probably 3-4 years ago. It really didn't yield good results, not even up to what random forests was doing, even being much more expensive in terms of computational power. But just this year, we have continued to work with this and retested and combine different techniques, and we are starting to see deep learning giving a few extra points on fraud detection that random forest. So it's definitely something that we are now looking with more attention. Based on the challenges and the algorithms we use, I wanted to go through basically how we work on a daily basis. And we call it the data science loop. So this is a standard, let's say, approach to how you do data science and how you do machine learning. And I wanted to go through how we do it, and basically then what type of services from AWS we also use to leverage this loop. And as I said, data science, it really is powered by, or it's improved by the number of times that you iterate. And Werner was talking early in the morning about all of the grunt work that needs to be done to do machine learning, and this is the type of work that we constantly look for automate more and more, but still needs to be done. So the first thing is all about the data. Garbage in, garbage out. So data cleaning and data loading, and then analyzing and sampling is definitely always the first step. Especially in financial services, data is never clean. It has been our learning since the beginning. We spend a lot of time just making sure the data is consistent and that we can really leverage that data in a consistent way. So loading and then understanding the data is super important, because every customer will have a different type of data set, of reality. Sometimes you're dealing with different regions, for example, data sets from Europe, data sets from the US, from Asia, and the patterns are completely different, because in the end, we are talking about people that are doing their lives. So analyzing the data is super important for a data scientist. The third step, and in general, I'm doing this, or the visualization here is how much time in the loop is spent, is represented also by the size of the rectangle. Something that many times I don't see exposed on presentations about data science and machine learning, which is feature engineering. This is probably not even accurate. I would say that feature engineering will be bigger in terms of time consumption. But at least in our use cases, if you just clean the data and try to train a model, you're not even getting, I would say, a mediocre model. You will have a really bad model. If you just put the data that comes into a machine learning model, it won't detect any type of fraud. You might find a recall of 15%, 20%, and the industry is asking you 70%, 80% of recall. So it's a job of the data scientist to really get more intelligence about that data and basically improve that data set with very different types of techniques. For example, one of the techniques that we use a lot is, because we are dealing with people's behaviors, we do a lot of behavioral profiling. With this, I mean you can put what's the average transaction amount over the last hour, over the last week, over the last month, over the last 6 months. And basically, we are defining what are the patterns of that person. Another example is when we are dealing with online transactions. We get an IP of where the transaction was made, the browser, but the machine learning model basically won't understand what's an IP. So what the data scientist then does is it needs to enrich the data set based on that information. It can find what's the country of that IP address. It can find if it's behind a proxy or behind a Tor node, and all of these signals are then more discrete to be able to allow the algorithm to learn. Then we go to model building, and this is where most of I would say the presentation's focus is. We need to build a model. We can use any of the algorithms there, and then we start optimizing the model, mixing up all of the knobs and the parameters that the model has. As we are doing this optimization, we always need to evaluate and compare these models, because that's the output of the process, and you need to find what's the best model that you have trained. And all of this is the, let's say, the non-real-time part. Then you go and, okay, you have a model. I want to use it in production. So the first thing is you need to integrate it in a runtime environment. Running the model is really not a challenge any time nowadays, because you have a lot of services that can run a model. The main challenge is, as I explained about the feature engineering, you will get data in. You'll have to do a number of calculations and processing to transform that data, and then it will be put in the model. So that runtime integration, many times it's very challenging, because we want to do it in 2 or 3 milliseconds. So you want to be, for every transaction that arrives, you want to know, okay, for this transaction, I know the credit card number, so I know which person is doing this transaction. What was his or her average amount over the last 6 months? This person is abroad. What's the average amount that this person usually does abroad versus when you are at home? Because your spending habits are different when you are traveling. So all of this needs to happen under these 2 or 3 milliseconds. You need to go through all of this data to be able to get all of these signals that are needed. So that's why there is a runtime integration part and a benchmarking part. And I told you that this is a loop, right? So in fact, these are multiple loops. I've run you through all the stages of the data science loop, but then now I'm going to run you through different loops that exist and why do they exist. The first one is you go until the evaluation phase and compare it, and you plateau on the results that you have. So basically, you have optimized as much as possible. You have done all of the iteration on the features as much as possible, and you don't know what to do more. So what you do, in fact, is you go back, you go to analyze and resample the data. You need to get more insights to what's in the data. You will just go free analytics, try to do more charting, you go investigate the fraudulent transactions, try to infer certain types of patterns that you can discover and help then the machine learning models to learn. Another part is when you evaluate, you just refine your features. This, I would say, is the most common one that our data scientists do, because, again, it's where a data scientist can give more value. Basically, they analyze the data set, which then translates to the feature engineering, is the part that is harder to automate. Even though we are right now, we are going even to launch this year, some capabilities where we are trying to automate in an intelligent way this type of work of feature engineering, where we generate new features based on the domain that you are working. And the last one is what, for example, today even SageMaker can already automate for you, which is basically just doing parameter optimization. There are a number of techniques for hyperparameter tuning, and in fact, it's just trying to do a search on the parameter space to get the best model. So now going to the tools that we use. For the data science modeling part, basically we are running all of this on EMR. We still, because all of these specificities of the domain, we still need a lot of flexibility, and our data scientists still need to have their flexibility. So in practice, EC2, where we deploy our machine learning platform. We basically leverage a lot of open source technology, and we try to put already a lot of business knowledge that we have to help doing machine learning on fraud detection. So there is a lot of knowledge already encoded in the platform. We use EMR for distributed processing. It's very important for us to have these auto-scaling capabilities because data scientists work in many times in certain types of batches. So it's very normal for us that the cluster is for 1 week almost idle or doing very simple stuff. So the cluster scales down to just a few machines, and then suddenly the data scientists want to do a number of tests, and the cluster scales to a few dozen machines. And that's very important for us because we don't want the data scientists to rely on IT or ops to change the cluster size. S3 is also essential for us. Once again, one of the hurdles we usually had when we were running this, and we still have some clusters on premises, is that the two main problems when you are working with data scientists and running a cluster in-house is you are always out of storage and you are always out of power, processing power. So for us, S3 was also very important to make sure that we never run out of space. We had, of course, to implement some of controls to not blow up on costs, but we never block data scientists because of this. Another thing very important, because we work with customer data and PII data that is very sensible, is that we can also manage all of the access control through the identity management system, which once again on premises was a nightmare to manage all the access. When data scientist joins a new project for this customer, we need to update the permissions, then he leaves, we need to update the permissions again. Doing this in a centralized way was super important for us. And last, we also use Lambda, because as I mentioned, we have the runtime and the data science platforms, and we need to refresh the data. So with Lambda, we are automating basically the data movement from RDS to S3, and it was always a challenge for us, being asked by the data scientists, no, now I have to move the data again, and because all of these environments are PCI, there is a ton of process that you need to do a data movement to be compatible and follow the process of PCI. So on the runtime scoring, EC2 again to running our platform. It was very important for us to have different types of instances. We leverage a lot the high memory instances because we do a lot of in-memory processing. There is an error there. It's not EC2 the second, but is RDS. So RDS is our database that we use for real time. It was super important for us to have high availability without effort. We still deal with a lot of customers on premises, and this is one of the topics where we are always asked, either with Oracle or Postgres, okay, now how we do it in a distributed, how we do it in multi-data center. And sometimes we just need to say, okay, call Oracle. You'll have to pay a bit more of money, but it's super hard to be doing all of these deployments one by one and have this type of characteristics. So for us, not having to worry and hire DBAs to do this for us, it was super important. DynamoDB was probably the first serverless service that we started using. Once again, on premise on our customers, we use Cassandra to have a fast cache that doesn't scale based on the data that we have, but on the volume of transactions that we have. So going to Dynamo also really helped us to simplify our operations. In fact, we moved to Dynamo because we looked at the operational model that we needed to have immutable images, and it was a nightmare. So it was just easy to move to Dynamo than building the automation on top of a Cassandra that was maintained by us. And Elasticsearch to support all of the dashboarding and analytics that we need to give to the analysts. So just to close, in terms of future work, as I said, we are working on deep learning, and SageMaker is under our radar to see how can we leverage the evolution that AWS is doing with this. Serverless is clearly the way for us to go in terms of reducing costs and simplifying our stack. So Aurora serverless, we are already moving to Aurora, but with the announcement of going serverless, it's even better for us. SQS, because we still operate some RabbitMQ clusters, that's also one of the things that we want to simplify, and Lambda for replacing ad hoc processing. The last thing about infrastructure, and I was just talking with Carus about this. We are now moving to Kubernetes, and one of the reasons why we didn't do it in the past yet is because the majority of our customers was on premises, and going to a big bank and say that we run on Docker or Kubernetes, they would just say, we won't install that here. It's just not reliable enough for us. Not only now they are changing, but also as we are operating on the cloud, we are going to, we have launched now a project to review our architecture to run on Kubernetes. And in fact, our goal is to go directly to Fargate instead of going to EKS and still manage some of the infrastructure. And that's it from me. Thank you. And I hope you liked it.
Thank you, Diego. Soy lo último que os separa de las cervezas que están en el piso de abajo, con lo cual agradeceros muchísimo que hayáis estado con nosotros hoy en el Summit 2018 de Amazon Web Services. Una vez más, si queréis hablar con nosotros y tenéis dudas, tenemos toda una barra de expertos también abajo donde las cervezas, que estarán encantados de hablar con vosotros. Y bueno, muchísimas gracias y espero que lo hayáis disfrutado. Gracias.